Hello viewers. Today I discuss the topic multiplication of two DFTs and circular convolution. So to understand this topic, you should have a concept of DFT and circular shift. This is the prerequisite of this video. Now see multiplication of two DFTs and circular convolution. Here what you have to do, first you have to take two sequence x1 in and x2 in. Now in this two sequence, if I apply DFT in point DFT, so we will get x1k and x2k just by applying simple formula of DFT. So as we know, DFT applied for a periodic signal, so k should be 0 to n minus 1. Here also k value should be 0 to n minus 1. Now after multiplying these two sequence x1k and x2k, we will get x3k. So that means we are doing here multiplication of two DFTs. So after multiplying two DFTs, we are getting x3k. Now if I want to check that what is the value in time domain again, so for that we know you have to apply IDFT. So using IDFT, if I apply IDFT here, we will get x3m. So after applying this IDFT, you can see this is the formula. So that formula we can compare with circular convolution. Now here we can see that this is your actual formula after applying the IDFT. That means, so in frequency domain, so there are two DFT. If I multiply them, then what we'll get? In time domain, we are getting circular convolution. So because of this advantage of frequency domain, we always prefer frequency domain over time domain, because circular convolution, to apply circular convolution, you can see how many steps are there. So one step is at that right side, n is the parameter. So if I take minus sign here, minus sign common, then see I'm showing you this term we can represent this way also. X of 2, take minus sign common, then n minus m. Okay, this is n and then minus m. So when minus sign is there, so minus sign representing the reversing in timed sequence. So first step we have to do, that is a reversing. Then the under double bracket, when I am writing n minus m, so that representing circular shift. So the next step is your circular shift. Then the multiplication is say x1 sequence and x2 sequence, so multiplication between these two. So after then multiplication is the third step, and the addition. So addition is your fourth step. So there are total 4 steps you have to compute, then only you can get circular convolution result. But in frequency domain, you just have to multiply them and you will get the result. So that's it why this is the advantage of circular convolution in frequency domain. Now here you can see that symbol of circular convolution we use, there is a circle and in between there's n, capital N. So this is the symbol of circular convolution. X3m gives you circular convolution between x1n and x2n. Now, so circular convolution you in the previously, so there another convolution also, you know, that is the linear convolution. So this between these two there is some difference. Now before discussing that difference, first you see this expression of linear convolution. So this is the expression of linear convolution. Now if you compare with circular convolution, all the steps are again same except that shift. Here we do, for linear convolution we do linear shift, but for circular convolution we do circular shift. So that is why here one symbol you can see double first bracket we are using. See, double first bracket means the circular shift. Now, other than another difference is also there. You can see here we are using the limit for n equals to 0 to n minus 1, which is a finite limit. But for linear convolution, we use infinite limit. Okay, this is another difference. Means any sequence, even if the sequence is infinite in duration, infinite in length, that all, then also we can apply linear convolution. But for circular convolution, always we need finite length of sequences. Now before discussing this numerical problem, first I want to show you some differences between this linear convolution and circular convolution. So in linear convolution, say there is x1n and x2n, two sequence, and x1 in length is your L and x2 in length is your M. After applying linear convolution, we will get x3n or x3m. So x3m length should be L plus M minus 1. So length of x3m after doing linear convolution, length should be L plus M minus 1. But if I consider the circular convolution, then say x1 in length is L again and x2 in length is M again. Then the length of x3m should be max of L comma M. So we have to find which length is L or M, which is greater. If L is greater, then you have to choose the length of x3m should be L now. This is the main difference. And for circular convolution, we know we are going to use again all 4 steps, but that extra steps is in linear sieve. Instead of linear sieve, here we have to apply circular shift. Now say there are two sequence. Now if you consider this numerical problem, say one x1n is given and x2n is also given. Now if I consider this numerical problem, you will find, say here both the length of the sequence is 4. x1 in length is 4, x2 in length is also 4. Now if I consider, say x1 in length, say it is given like this, x1 in equals to say 1 comma 0 comma 2 and x2n is this one. So then means there is a length mismatching. So first step of circular convolution is first you have to make the length for both the sequence same. So how we can do that? We know there is a well-known method that is called zero padding. So to make the length equal, here you have to pad one extra bit or extra sample using zero padding concept. So after adding one zero, that is called zero padding. So now length of x1n becomes 4 and x2n length is already 4. So first step is length matching. First make the length for both the sequence same. Even if it is dissimilar, then pad extra 0. After doing this, here the next step is the reversing or folding. So suppose we want to make x2n folded or x2n shifted. We want to shift that x2n. Then what we have to do? First we have to take the reverse value of x2n. So for that, draw a circle and put the values. Say first value we can write, this is x2 we are using. So this is x to 0, this one is x to 1, this is x to 2, and this one is x to 3. Now put the value. X to 0 is your 1, this is your 2, this one is 3, and now this is 4. So this is simple x to n. Now if I want to shift it, or first step is your reversing. If I want to apply the reversing property, so what we have to do, again we have to draw another circle. So draw another circle and put the value just in opposite order. Initially we use this anti-clockwise word as the positive direction. Now we can use the clockwise direction is your positive direction. So for that, here you have to write this way. That means this should be same. This is your reference, x to 0. Now start set clockwise. So clockwise means this is 0. Clockwise means x to 1. Here it will come x to 2 and then x to 3. So we are putting the value clockwise now, and this we can write under this, inside this circle, x2 double bracket minus n, here capital N. This way you can write. Now, so this is your reversing. Now after reversing, now you also plot the x1 in sequence. So if I want to plot the x1 in sequence here, say this is your x1 in, and we already considered that anti-clockwise direction is the positive direction. So just put the value. This is x1 in. Now put the value. This is the 0th position, we know, already discussed. So the 0th position value is 1, then it comes 0, then this is 2 and 0 again. Okay, so this position is x1 0, this position is your x1 1, this is equals to x1 2, and this is your x1 3. Now try to remember the, say I am writing it here it again, the formula of circular convolution. So that is your x3m equals to summation n equals to 0 to how much, because we are using 4 length, so we can apply 4-point DFT here. So length should be 0 to n minus 1, means 0 to 3. Now x1n into x of 2 minus of n minus m, complete the expression. Here it is 4, because n we choose 4-point DFT, so n equals to 4 here. So first operation is reversing, we have already done. Now the range of m is also same, 0 to n minus 1, that means 0 to 3 again. So first we are going to put m equals to 0. So if I put m equals to 0 here, so what we will get, m equals to 0 means this is this part becomes x2 minus n. Okay, this part becomes x2 minus n, which we have already plotted. Okay, which we have already plotted. So now we know what is your x2 minus n. Now after that, what is the operation we have to do? Which operation? That is the multiplication. We have choose m equals to 0 now. So we are going to find x3 0. So x3 0 equals to, now m equals to 0, and we already plotted this. Now next question is multiplication. So here we have to do multiplication position wise or sample wise. A position means this position should multiply with this position, then again this position should multiply with this position. Now if I multiply, see this position value is here 1, and what is the value of this position? X to 0. X to 0 value position is 1, and here value is 2. Here value is 3, and here the value is 4. Now multiply. So if I multiply position wise, then 1 should multiply with 1. Then first we can write x3m equals to 1. Then come addition. Now plus. Then the at this second position. Second position value is here 0, and here it is 4. Here it is 4 and it is 0. If I multiply, we will get 0 again. So the next point should be 0. Now plus. Again, this way multiply the third position and fourth position. So third position value should be, here it is 3, here it is 2. So value should be 6. And in the last position, see values are here, it is 2, and here it is 0. So value should be 0 again. Then means here value comes 7. So this way again you have to choose m equals to 1. So I am showing you for m equals to 1 also. Now here I am showing you for m equals to 1. If I choose m equals to 1, then I can write here x3 m equals to 1 means x3 1 equals to, what will write? If I write m equals to 1, so now replace here m by 1. So that means what? N minus 1. So first you have to do reversing, then we have to shift it by 1 unit but circularly. So after shifting it by 1 unit circularly, so what will be the diagram here? We have to shift it by 1 unit. Now we have to shift it this value. So x to n we have to shift. So x to n should be, that means this position comes here now. This position will come here. So this way you have to shift. Now I am drawing this part for you again after shifting it by 1 unit. Now see, again draw the circle. So this value should be your x2. You can write x2 minus under double bracket n minus 1, and n is your 4. Now choose the value again. So already you have to shift by 1 unit. So initially it was initially the value was x2 0 here, x2 0 here, but that value will be shifted by 1 unit. So here we can shift it. So you can write this value is your, now this is your x2 0. Now this value becomes x2 1. This is your x2 2, and this one is your x2 3. Now just put the value. So this value becomes 1. Now this value is already given. So this is your now this is the value. Now just multiply again position wise. So if I multiply them, so how much we will get? So first position is your 2, then again 0, then 8, and the last is again 0. So it gives you 10 here. So this way, the same, by applying the same rule, you have to find out other two value also, because m value is from 0 to 3. So for this, if you find, already we know, so here we can write the x3 m value, all values. So first one we can write this way, x3 m equals to, put a second bracket. So first value we got 7, then 10, already I have shown you. But next two, if you calculate in the same way by putting m equals to 2 and m equals to 3, you will get the answer. This is the answer. Now see, so answer is 7, 10, 5, 8. Now after doing everything, now we have to check that whether your answer is correct or not. So how we will check it? So come here. So I'm writing it again. So the x3m we got 7, 10, 5 and 8. Now see, if we add them, if we add each sample of x3m, how much we'll get? We'll get 30 here. See, add each sample, we'll get 30 here. Now add x1n sample. X1n sample is 1 and 2, that means 3. So here we are getting 3. And for x2n again add, so here if you add here, you will get 10. Now multiply 10 and 3. So it becomes 30 again. That means if you, this is the cross check process, if you find the summation of all the x3m samples is equals to the multiplication of, say, summation of this and summation of x2n, then you can say that your process is correct. Okay, otherwise you have to recheck your process again. Now this method what we have discussed till now, this method or this approach is called graphical approach. This approach is called graphical approach. Same thing also you can do using another method. That method is called concentric method. Most of the books prefer this one because this is also easy. The same thing you can do using that concentric method. So concentric method means here you have to draw two circle first. Here I am showing you. First draw two concentric circle and point one x1n and other one is x2n. Now after that you can apply the concept of convolution or circular convolution. So first I am drawing one circle here, one bigger one. Okay, and then draw another circle. So the outer side, say whether this is x1n and the inner side is your x2n. So what you have to do here? So first you have to find the inverse of this inner circle. So inverse is your means minus n you have to find. Already you know how we can find this. So just put the value here. So the value should be 1, 2, 3 and 4. And here also put the value. So here value is 1, 0, then this is 2 and this is 0. Now what I have to do? Multiplication. So for m equals to 0, multiply this into this 1 again, this is 0. This 2 if you multiply 6, this 2 if you multiply 0, then means again we are getting 7. Now after that we have to move it by 1 unit. So or shift it anticlockwise by 1 unit, the second step, then again multiply. So that gives you the value for m equals to 1. So and again position wise do the position wise multiplication, you will get the result. So this way you have to shift it by 3 times, and already m equals to 0 we did, then m equals to 1. After that m equals to 2. So again another unit shift you have to do and again do the multiplication. So as we are drawing two concentric circle here, so that's why the name is concentric circle method. So this way also you can solve the circular convolution method. Now another easy method is also there, that is the matrix method. The matrix method means here you have to draw one matrix. That matrix represent the shift. That matrix represent the circular shift sequence, and here you have to write the x1 in value. So x1 in, so that is your 1 0 2 0. So this gives you x3 m. Okay, or you can write x3m in the form of one-dimensional matrix like this. So first value should be x3 0, then x3 1, x3 2, and x3 3. Now put the value. So first one is here, it is representing x2n with circular shift. So how we have to write? First write 1 2 3 4, then shift it by 1 unit. How will do? Have to start from the second row. 1 2 3. So 4 will come here because of circular shift. The next line again start 1 and 2. So here it will come 3 and 4. Then 1 here. So 2, 3 and 4. Now simple do the multiple matrix addition and multiplication, because here this row should be multiplied with this, give you the result that gives you x30. Now when we multiply this to this again, this gives you x31. So this way you have to complete the result and you will get the same result again. So this approach is called matrix approach, and this approach is quite easy. Now, so these are the total methodology of how you can find out circular convolution when two sequences are given in. Now I am giving the brief that if x1, the conclusion I can say, so I am reminding you the steps. If there are two sequences x1n and x2n, first step is to find out whether the length is same or not. If it is not, then by zero padding make the length same. Then draw circle, or you can use this one first. Next step is you have to choose that which sequence you want to shift, which sequence you want to choose for circular shift, and then you have to choose that sequence and find out its time reversal. So that means x2 minus n. After that put m equals to 0 and multiply position wise. Then for another shift you have to do 1 unit shift, and after doing that shift again you have to multiply and put the value that gives you for m equals to 1. So this way you have to continue and you will get the final result. After getting the result you have to cross check whether the answer coming correct or not. Thank you.